Introduction to Computer Architecture. A computer is a system that processes data using hardware and software. It follows the von Neumann architecture, which consists of Central Processing Unit (CPU), the brain of the computer, memory (RAM), temporary storage for data and instruction, input-output I/O devices for interaction with the external world, storage, hard drive (SSD), permanent storage for data and programs. The role of the CPU. The CPU executes instructions from programs. It consists of control unit (CU), fetches, decodes, and executes instructions. Arithmetic logic unit (ALU) performs mathematical, analytical, and logical operations. Registers fast storage locations for temporary data. Clock speed determines how many instructions the CPU can execute per second, measured in GHz. Memory hierarchy. Computers use different types of memory for efficiency. Registers, fastest, located inside the CPU. Cache memory, faster than RAM, stores frequently used data. RAM, random access memory, volatile memory for active programs and data. Storage, HDD, SSD, non-volatile memory for long-term storage. Memory management. The operating system handles memory allocation and deallocation. Instruction execution cycle. The CPU follows a cycle to execute instructions. Fetch. The CPU fetches the next instruction from memory. Decode. The instruction is decoded into commands. Execute. The AU performs the required operation. Store. The result is stored in memory or registers. Input-output I/O operations. I/O devices, keyboard, mouse, display, etc. allow interaction with the computer. I/O controllers manage communication between the CPU and peripherals. Interrupts. Signals from devices to the CPU to request attention. The OS acts as an intermediary between hardware and software. Key functions. Process management. Handles running programs. Memory management. Allocates and deallocates memory. File management. Manages data storage. Device management. Controls hardware devices. Microcontrollers and embedded system. Microcontrollers are specialized computers used in embedded systems. They integrate CPU memory and I/O on a single chip. Common in mechatronics for controlling devices like motors, sensors, and actuators. Examples: Arduino, Raspberry Pi, ESP32. Conclusion: a computer works by executing instructions in a cycle, managed by the CPU and supported by memory, I/O, and the OS. In embedded systems, microcontrollers perform similar tasks but are optimized for specific applications.